right, sorry, I started on number 1 without recording. This is the odds of getting a heart with the first draw, the second card being a heart. So there's only 12 hearts left out of 51 cards left. And then on the third card, there's 11 hearts out of 50 cards left. So every time you draw a heart out, it lowers the number of hearts and it lowers the number of total cards. So that's why these are shrinking. So this would give us the probability of getting 5 hearts in a row. Not very good. Okay, anyways. They wanted us, well, they kind of wanted us to write this in factorial form. So, what is you guys remember what factorial meant?
Is that the one with the exclamation point?
Yes. And what does that mean?
All those things multiplied together.
It mean, what does 5 factorial mean? 5 times
4 times.
Right. Yeah, all the way down. Now you can put times 1, but it doesn't really do anything. Okay, notice this kind of looks like a factorial, right? The top kind of looks like 13 factorial until you get right here. So the times 8 times 7 times 6 has like been taken off. So how do I get rid of times 8 times 7 times 6? You divide by 8 factorial. So that represents the top. The bottom looks like 52 factorial, like 52 times 51 times 50. So 52 factorial would be on the bottom, except for we're missing times 47 times 46 times 45. So to get rid of the 47, anyway, that's what the book put. Do I care enough about that? Nah. So I think I'll do, they didn't put the answer in this form though. It'll make it hard to read. Oh, okay. Okay, there's going to be a 10 to 15 minute drill, so you're going to have to fast forward. I'm not going to close the video down.
It's just going to record the entire time. Let's try to skip one.
No, I don't want to like run it.
So they cross multiply.
That's why I said.
That's why I was
That's
saying.
why I said you're. Dude, you guys are
Grant, Grant was saying it was 52 over 47 factorial.
stupid. You said the large one goes on the top. And I knew it.
I was trying to tell Grant how to do the problem, and he wouldn't want to. He would not.
I'm just not gonna show up on Friday.
How did we get to
Like, the
I'm
school or the
telling him,
Zoom.
I'm telling him they cross multiply,
Oh, wait, Carolyn.
and he would
That's
not.
not cross multiply.
Girl, we would die.
That's what he was saying.
That's 13 times 47 over
That'd be
8.
so- You're a redneck.
Yeah.
Yeah, I really
That's what
I
I
realized
was
how
saying.
you were
Grant
getting
not-
it, and I was like,
Grant
sure,
was
sure,
not
no,
listening.
it's like,
It's so funny. Listen to
oh.
Alright, we'll just say.
Nothing took me 4 stones.
Okay.
Are you just
Huh?
supposed to?
Well, I'm just gonna say that was it. This is what the book put. If we did that, that would give us the answer.
No. Grant, don't throw it.
Brian, we only have 9 plus 10 minutes.
Why not?
How many minutes?
Alright, so on B, yeah, we're gonna use them all too. What's the probability of getting no hearts? So what's the probability that your first draw would be no hearts? How many not hearts are there? 52 minus 13. 39 out of 52. Okay, how many draws were there? 5? So, not hard, not hard. 5 events.
38 out of 50.
Now there's only 38 not hearts out of 51 cards, and 37 out of 50, and so on.
This is why you suck at your job.
My job.
Yeah.
What's my job?
Setting up the stage.
Okay, the book didn't actually plug this in, they just wrote 39 factorial over 34 factorial. So, you guys understand why they put 34 factorial down here? Because they would get rid of the, like, times 34, times 33 stuff. Okay, and on the bottom is 52 factorial. And it's missing 47 factorial over here, so they put that on top. I don't know. So the reason I'm doing this form is because they didn't write the answer in the other form. So,
So,
Is this gonna be on the test?
no, just the, I mean, this will be on the test, yes, but not the factorial version, no. But doing this, yes. C, at least one heart.
that'd be like 1 out of 52.
Yeah, but it's at least.
So it'd be,
Okay, actually, we don't need this. So, at least one heart is the opposite of no hearts. So really what we need to do is figure out what's no hearts, which one, A or B? That was B. So, yeah, if you just do 1 minus this probability, that will give you the opposite probability, right? You guys know what I'm saying? Like the chance, okay, we talked about this before. What are the chances of me choosing a boy at random out of this class? 4 9. What are the chances of me choosing a girl? It's 1 minus 4 out of 9, which is 5 out of 9. Because these are like the two things that can happen. It's either this or this. So they have to add up to 1. So the probability of getting at least one heart is like the opposite of getting 0 hearts. Does that make sense? So 1 heart means you could get 1 heart, or 2 hearts, or 3 hearts, or 4, or 5 hearts. So there's a lot of different ways that can happen. But instead of finding all those probabilities and adding them together, you can just say, well, it's the opposite of getting no hearts. So if you just do 1 minus no hearts, kind of like 1 minus 4 ninths is 5 ninths. 1 minus this would give you the probability of getting at least 1 heart. So that's all they put.
Can we do blue?
You tired of red?
Johnny feeling so blue.
I'm so blue.
I'm feeling black. Can we do black?
Grant.
Okay, number 3. This does not have the factorial thing on it. Just 1 and 2. Okay, a bag contains 5 red marbles, 3 white marbles. Okay, I'm going to write that down. 5 red, 3 white. 2 marbles are randomly drawn. My book's messed up. One after the other without replacement. So we're not putting the first marble that we draw, we're not going to put it back. That's going to affect the odds. What's the probability that the number of red marbles is 0? Okay. 2 marbles are drawn, so there's like 2 events. And we want no red marbles, so we want white, white. Okay, what's the probability that the first marble I draw is white? 3 out of 8. Okay, and then if that happens, what's the probability that my next marble will be white? 2 white marbles left out of 7 total left. So altogether, okay, this will reduce here. Yeah, it's kind of like A. They didn't put A, B's, and C's on it though. But yeah, that's the first answer. 3 and 28. Okay, the next question is, what's the probability of there being 1 red marble? Okay, that could happen 2 different ways. It could be our first draw is red, and then our second draw is white. Or it could be our first draw is white and our second draw is red marble. So we're going to figure out the probability of both of these and add them together to get the total probability of either of these happening. Okay, what's the probability that we get red on our first draw? 5 out of 8. What's the probability of getting, if we got a red on our first draw, what's the probability the second draw is white?
37.
Right, there's still 3 white left, but now there's only 7 marbles total left. Okay, what's the probability that our first draw is white? 3 out of 8. Because 3 out of 8 ain't bad. Okay, what's the probability that our second draw will be red after our first draw? 5 out of 7. 5 red, only 7 marbles left. Okay, even though these numbers are kind of switched around, it's still the same probability in both. Okay, what's the probability that this or this happens? Okay, they can't happen simultaneously. Either you get red and white or white and red. You can't get both at the same time. So the probability that this or this happens would be this plus this, 30 out of 56. But that does reduce if you divide by 2 to 15 out of 28. All right, did that make sense? Okay, the last question is that both of the draws are red. So we're looking for red, red. So probability that the first marble is red, 5 and 8. And if the first one was red, the second one, 4 and 7. Okay, if we did this right, what should all 3 of these add up to? 1, because these are all 3 possible outcomes. So there's 100% chance, 1 out of 1 chance, that one of these 3 will happen. 0 red, 1 red, 2 red. That's the only possible outcomes. Alright, anyways, you can kind of check your work a little bit. Number 5, we're almost done. We're almost done. Free concert tickets, A, B, C, D, and E. Free concert tickets are distributed to 4 students chosen at random from 8 juniors and 12 seniors in the school. So 8 juniors, 12 seniors. Airplane. All right. 4 students are chosen. Yeah. Yes. 4 students are chosen, so that will be our 4 events. Choose a student, choose a student, choose a student, choose a student. 4 events. Okay, what's the probability that all 4 are going to be seniors if you choose these at random? What's the probability that the first one's a senior? 12 and 20. Second one's a senior. And you just do a countdown. It's the final countdown. They put the fraction and the decimal on this one. I'm going to put the fraction. Okay, this time they did put A, B's, and C's. That kind of be nice if they did that every time. All right, B, exactly 3 seniors. Okay, this is where it gets a little trickier because that could happen more than one way. So it could be senior, 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 junior. Or it could be senior, senior, junior, senior. So how many ways could we get exactly 3 seniors? 4. Because basically this junior just keeps switching spots. So these are the 4 ways. The probabilities for all 4 will be the same. Okay, what are the probabilities? So let's just do the first one. First guy is a senior, 12 and 20. Second one's a senior, 11 and 19. 10 and 18. Okay, now this one will be different than the last one though, because it's a junior. So how many juniors are left? All 8. Out of how many students left? Only 17. Okay. This is a little different than yesterday because the probabilities, they don't look quite the same, but they will come out. Like if I did this one, I'll do it real quick. Times, okay, juniors, this would be 8 out of 18, and senior, 10 out of 17. So if you look at the fractions, they are different, but if you look at the numerators, they're all like 12, 11, 10, 8, 12, 11, 10, 8, and the denominators are 20, 19, 18, 17. So even though the fractions are different, they still come out to the same probabilities. Because even though the numerators are moving around. Okay, so, oh gosh. Whatever this answer is, there's going to be 4 of these. So you could add the same number together 4 times, or you could just say times 4. There's 4 different ways this could happen. What's that come out to? I'm looking for it. 352 out of 969. Okay, maybe I should start circling my answers. Yeah.
Why does it go 12, 11, 10, 8, and not 12, 11, 10, 9?
Because this one was a junior. I'm doing this. So the junior, there's only 8 juniors.
Oh, okay.
And at this point, there's only 18 students left. And then I went back to seniors, so there's still 10 seniors left out of 17. So the point I was trying to make is, though, even though these fractions are a little bit different, like this is 8 out of 17, this is 8 out of 18, the probability will be the same because all the numerators are the same and all the denominators are the same. The order's just mixed, but they do come out the same probability. Okay, C is we want exactly 2 seniors. Okay, this one was we've done something like this before, but it's been a while. So how many ways can this happen? Yeah, it was, you guys actually both remember that?
Yeah.
Did you say 6 too? Oh. All right. there was kind of a trick. You can do a combination out of the 4 spots, we're choosing 2 to be seniors. If you plug that in your calculator, it will tell you 6, which means there's 6 ways. I can try, sometimes I screw this up. So let's move this senior down. See if I can find all 6. And then I'll move this senior down 1. And then I'll lock that one. 1, 2, 3. There's one more. Junior, junior, senior, senior. Yeah, this is all 6 ways you can get 2 seniors. Okay. If you have 4 events and you're trying to choose.
I have a question.
Yeah.
Why does the second one have 3 guesses?
Oh, yeah, you're right, I screwed up. What did I mean to do? I meant to do junior here. Okay, anyways. Out of 4 spots, you're trying to choose 2 to be the seniors. That's always gonna have 6 ways that can happen. So what I'm gonna do is find the probability of one of these happening and take my answer times 6. Okay, I kind of forgot. The odds of being a senior are 12 and 20 on the first pick. The second one being a senior is 11 and 19. Okay, you guys remember how many juniors there were? 8, but now there's only 17 or 18 students. And now there's only 7 juniors out of 17 students. Because there's 6 ways this thing could happen, I'm going to say times 6. That's 2 out of 3. And the answer is 616 out of 1615.
We only have 2 minutes.
It gets easier towards the end. It's the ones in the middle that are harder because you got more combinations. Okay, exactly 1 senior. So how many different ways could we get exactly 1 senior?
Yeah, we just.
4.
To the-
Because he could be here, here, or here. So there's 4 different ways. So we're just going to take our answer times 4. 4 different ways this could happen. So the first one being a senior is 12 and 20. The second one being a junior, there's 8 juniors. So 8 out of 19. Two 24 and 1615. Now we could, the last option is no seniors. We could just do 1 minus all the other answers.
Is it the
But-
opposite of?
It would just be junior, 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 junior. So there's only one way this could happen. So it'll be 8 and 20, 7 and 19, 6 and 18, 5 and 17. We don't have to multiply by 4 or anything. There's only one way that could happen. All right. And 14 and 969.
So when's this due?
Bro.
Let's have it done by Thursday.
Okay.
Thank you.
It's for E. It's for the E.
Oh. What's the color?
What? 4 go to E?
That is for the E.
There's 3 answers on 4, is that what you mean?
Oh, okay, yeah.
You're kind of redoing number 3 with different numbers.
So 5 and 6 are the only ones E's.
The 5 only goes to D, it looks like. Or no, 6, yeah. 5 goes to E, 6 just goes to E.
Yeah, I think you want to.